In this video, I'm going to go over the notion of conjunctions, that is, and statements, and I'm also going to go over the rules that we can use with conjunctions, namely conjunction elimination, or and out, and also adjunction, that is, and in.
The first connective that I want to talk about is the notion of the arrow. So this is the conditional statement, or just called a conditional for short. What we're going to do now is we're going to get into the notion of conjunctions. Conjunctions are another kind of connective, just like if-then. Conditional statements are a certain kind of connective. Conjunctions are another distinct kind of connective too. And they function a bit differently, both in terms of how we translate them, and also in terms of the stuff that we can do with them. So let's start first of all with the translating. When we see conjunctions, they're going to be represented for us by the dot. Your book actually uses the ampersand symbol, which I can barely get away with making. You can use that instead if you want to, and I would accept it. Also, in logic textbooks, often you'll see what looks like basically an upside down V. So any one of those you can use. I'm going to go with this one, because I think it's the most distinct. So what do I mean by and here too? Because there's other words that mean and in English. So basically I'll just say this. If I had A, and I can make A stand for anything, and then I had B, okay, we can make B stand for anything. Just for the sake of simplicity, let's say A stands for today is Sunday. And let's say B stands for it is passive voice, but we'll roll with it for here. It's raining. So if I said today is Sunday, I said all of this. Today is Sunday, and so today is Sunday, and it is raining. And I've already established here A stands for today is Sunday, and B stands for it's raining. How would I write this? Today is Sunday, and it's raining based on this, A dot B. However, instead of the word and here, there's some other words I could use instead, and it would still be represented formally the same way. So let me actually stick this down here. So A dot B in this instance stands for, because of the glossary that I gave, A stands for today is Sunday, B stands for it's raining. Well, hey, where did this A and B come from? I just picked them kind of randomly here. But I'm saying that they stand for this. But what are some other words that mean and? So some synonyms for and. So there are a bunch. I could say yet. I could say but. I could say although. I could say also. I could say, here's some other spicy ones. I could say moreover. Nonetheless. Some of these are silly. We don't use too often. But I want you to know that they exist. Nevertheless. Okay. Additionally. And there may be others too, but I think like two L's in there. All these we could substitute the word and for any of these, and it would work here. Some of them sound clumsier in English than others. So I could say today is Sunday, yet it is raining. How would I represent that? Same thing, A dot B. Today is Sunday, but it is raining. A dot B, same thing. Today is Sunday, although it's raining. A dot B. Today is Sunday, also it's raining. A dot B. Today is Sunday, moreover, it is raining. Today is Sunday, nevertheless, it's raining, and so on with these others. Okay, all of these, the dot means that there's a conjunction. So whatever, I think and is the most common one we use, that's why I'm rolling with that one. But we could pick really any of these other these. We could say, oh, these are nevertheless statements. Well, let's go with and, because it's the most common. But these, so and, yet, and but are all logically equivalent to one another. They mean the same thing, that the two simple statements are being conjoined. Unlike with if-then, if and the then kind of dictated that whatever follows if has to be on the left side of the arrow. Okay, it has to be, that's called the antecedent. Whatever's on the left side of the arrow is what follows if. With and, it doesn't really work that way. Both sides are equal, like an and statement. Like if I said like if I work, then I get paid, that's different from saying if I get paid, then I work. Okay, those are two different statements. They have different meanings. Whereas if I say today is Sunday and it's raining, really that's the same thing as saying it's raining, and today is Sunday. I just flipped it, but the meaning doesn't change, okay, in terms of what's going on. Okay, so there's kind of a symmetry of sorts going on there. We'll talk more about what technically what that's called later on in the semester, in terms of being able to flip it around. Okay, technically it's the commutative property, if you really want to know. But here, what I want you to know for now is simply that the order kind of doesn't matter. Now I'll say, if you see it in a certain order, go ahead and write it out in that kind of order. But there's a sense in which the meaning doesn't really matter, that either side can be flipped. That's not the case with arrows. Okay, you can completely change things change the meaning of things if you start flipping arrows around. But with dots, that is with and statements, conjunctions, which side comes first in a certain sense doesn't matter. I'm going to say when you're translating, translate it as is in the order that it comes. But the meaning doesn't change when you flip sides. The meaning of conditional statements does change considerably when you flip sides. So let's take a look at a few more things here with conjunctions, because now there's also some new moves that we could do with conjunctions. So far we had one move in our move set, and this is what was going on quiz 2. This is what was going on in the previous sets of videos, and that's the stuff that we could do with arrows. There's really only one thing at this point that I said we can do with arrows, and that rule is called arrow out. And the way that rule works is, it says if you got this situation, you got an arrow, you got a left side of an arrow, then you can get the right side of the arrow by itself. We spent a lot of time practicing that. So what we're going to learn here now are two new moves that we can use, that we can only use with dots, that is with conjunctions. So as a reminder, we're dealing with conjunctions. This stuff hasn't gone away. It only works on arrows, but it hasn't gone away. We're still going to use that, but it's kind of like we need new tools for a different task. So for example, if you're trying to hammer in nails, a hammer's great. But if you're trying to hammer in screws, it's doable, I suppose, there. So maybe this metaphor doesn't work completely, but it's sloppy, right? So what you want to use with screws, a screwdriver. Then you want to figure out, oh, do I need a Phillips? Do I need a flathead? And do I need one of those, hex screwdrivers? What do I need to accomplish this task? So basically, what I'm going to say here about conjunctions, this is the tool set that works with and statements, stuff that you can do with them to get what you want out of it. Okay, remember conjunctions are dots, they're and statements. Okay, and so they work differently from arrows. Here's what we can do with them. So first of all, the first skill that we've got, I'll say this with conjunctions, is this one. I think this is the simplest one. We've got what's called conjunction elimination. Sometimes it's called conjunction annihilation. Cool, that's the technical name for it. What does that mean? Well, the nicest way I can put it, like conjunction elimination, conjunction annihilation, conjunction destruction. The and is going away. What does that look like? Well, and let's take the exact same stuff I was using a moment ago. Let's say A stands for today is Sunday, and let's say B stands for it is raining. Okay, let's say that's the case, as we had it just a moment ago. Well, here's the way conjunction elimination, the shorthand form of which is called, I call it and out or dot out. It looks like that. So just like this, technically, this arrow out, there's a technical name for it, modus ponendo ponens, which you'll never need to know that technical name. That's not going to be on a quiz or anything like that. Okay, that's just for free. It's called modus ponens, modus ponendo ponens. Mode that affirms, or the long version, mode that affirms by affirming. This conjunction elimination, and out, or dot out. Why is it called that? Because it kind of gets the dot out. Now, it's not the same thing as arrow out. So like this one, the way this one always works 100% of the time. You got an arrow, you got a left side match. That left side match is like a key that unlocks this and makes this go away, so that you can then unlock the consequent, the right side of the arrow by itself. Okay, that's a very special process. It only works with arrows. Okay, there's other moves with arrows too that we'll learn later on. Here's the way conjunction elimination works. It says you've got this. Okay, so here's your assumption. You've got A dot B, or whatever conjunction we've got. We'll say we have that as an assumption. You got this. Conjunction elimination says when you have an and statement, okay, when you got a dot like this, what you can do with it is you can break it down into its two parts. Okay, so in other words, dots you can always slice in half, right down the middle. So you got a dot statement, you can break it into its separate parts, and that's perfectly fine. So this breaks down, now, unlike arrow out, where we can get only one thing out of it. So with arrow out, we're starting with two things, then we get one thing. With conjunction elimination, we actually get two things. Okay, or we can get two things. Actually, let me keep those on the outside. We can get this, and we can get what two things? Well, you get the two parts, you just get them separately. So in other words, and works this way. It's almost like, imagine you have two Legos. You got them together, what can you do with them? Take them apart, and now you've got them separately, and that's perfectly fine. You can't do that with arrows. Arrows you can't just break apart. They don't work that way. Okay, you break an arrow apart like that, you've done something wrong. Okay, it's an error. It doesn't work that way. Then, because here's what would happen. If you could just break arrows apart, then you'd have something like, if today is Sunday, then I'm the king of France. And if I just break those apart, now I have I'm the king of France here, and now all of a sudden I'm the king of France. That's nonsense. Whereas if I had something like today is Sunday and it's raining, and I take these apart, they still work by themselves. So that's why that works. So, and that's exactly what we get here. What two things do we get? One thing, and then the other thing. And also when we break it apart, the order doesn't really matter. Okay, so just like, I could take this pen that I have here apart. Okay, there you go. It's actually more than two pieces, but let's say I got these two pieces. I could put this one down first and this one, or I could do the other thing. I could put this one down first and then this one. It doesn't matter. It's the same thing. Okay, so I could put A and B down, or I could put B and A down. The order does not matter. I would do it in the way that it comes, personally. Okay, that makes the most sense to me. And then what I do is I say here, I log what I did. So how did I get this A by itself? Well, I did this one move. I did and out. Where was the source material? Line 1. Okay, then I need to log this. Where did this B come from? I also did and out. Where was the source material? It also came from line 1. So this is different from arrow out as well. Arrow out, it needs two sources in order to work. You got to have an arrow and you got to have a left side match. And you can get the right side out. Okay, that's what you get. With conjunction elimination or and out, you start with an and statement. Basically, you can just break it apart. Like as soon as you see an and, just break it down into its two parts. And then you just say, oh, I did the thing where you break ands apart, and you only have one source. That's what makes this one different. This one only has one source. You can get two things out of it, but it only has one source. What's the one source? The and statement that we had in the first place. You just basically break these pieces apart. They're not glued or fused together. The arrows are. Those arrows, everything in here is inexorably linked. There's no, unless you have the key to unlock it, it doesn't work. It doesn't work that way. You can't just take it apart like you can with an and out. So don't mix up arrow outs and and outs. And at this point, that's what I see happen sometimes at this point in the semester is people will say something like, oh, I had A dot B, and then I got A and B, arrow out. No, don't mix it up. Don't mix up your arrow outs with your and outs. They're two completely separate processes. And here also, just don't mix up arrows and dots. Make sure you're making them as distinct as possible when you're writing them up. But this is one, I said, of two moves that we've got. Let's take a look at the next one. All right, so let's talk about the next rule we've got. But before I do that, a little bit of review. We got these two rules in play. We got the arrow out here that only works with arrows, where if you got an arrow statement, you got a left side match, you can get the right side out. And we also got this one. This is and out. If you got two things put together with a dot, you can just slice them right apart and you can get those things separately. That's fine. The next one we're going to talk about is adjunction. I've heard it called conjunctive construction, conjunction construction, building conjunctions. I'm going to call it dot in or and in. And basically, it is simply and out in reverse. So let's take a look at what this one looks like. So this one says this. And let's use the same things I've been using. So we'll say we've got our A's and B's here. We'll say A is, today is Sunday because I've been using that one. And let's say B is, it is raining, as I've been using so far in these examples up to this point. So let's say I had these things separately. Let's say I had, today's Sunday. I've got that. That's an assumption. It's just something that I said. Today's Sunday. And then I said completely separately, oh, it's raining. And I had that as an assumption. So these are the things we've been given. Separately, today's Sunday. It's raining. What can I get with that? Well, I can put them together. Okay, so I can get this. I can just say A dot B. Okay, how did I get that? Well, I put them together with a dot. I stuck an and in between them. And then I just say, okay, where was my source material? Well, I stuck line 1 and line 2 together. That's what I did. Okay, that's all adjunction is. Like I said, it's this backwards. If you can take them apart, you can also put them together. Okay, and I guess you could go back and forth between these. You could take them apart and put them back together. Like Legos, and I'll take my pen here again. If you got two pieces, okay, this is the way adjunction works. I have these two pieces. I can put them together. Here's the back, here's the front. Now, also with adjunction, what I can do is just like I put it together with the back and front one way, I could also, with the pieces, put them together the other way. And that's perfectly fine as well. So let me go ahead and put that I can do that up here. All right, so and I'm not going to put it as a line number 4. I'm just going to say we could have an alternate version of line 3. I could put B.A. It's just as fine as the original line 3 that I had here. I'm going to say it's and in. Here I'm just going to say the order a little bit differently. Now, I'm going to say this right here too. As long as you got the right numbers in here, I don't care about the order. The reason why I'm doing it this way, this is my preference. I'm saying, oh, the first thing I put came from line 1, and the second thing I put came from line 2. That's why I'm putting it in that order here. Same thing here. The first thing I put came from line 2, and the second thing I put came from line 1. So that's why I'm putting it that way. But in both cases, I'm using and in. And the meaning doesn't change. If I say today is Sunday and it's raining, and then I say it's raining and today is Sunday, they mean exactly the same thing. Okay? There's no change in the meaning. Whereas, if I took an arrow and turned it around, that does something completely different. That completely changes the meaning of what's going on. You can't do that with arrows. Like if you see an arrow, if you say if this, then that, oh, I can just flip it around. No, you can't. With and statements, yeah, you can build them however you want. Now, probably if I tell you, say, it's raining and today is Sunday, like I want that, like I'm saying solve for B and A, then you're probably going to want to put it in that order, okay, even though there's a sense in which they're logically equivalent. So these are actually all the rules for conjunction. You've got your and out and in. These are the 2 rules with conjunctions. Let's move on to doing a few things with conjunctions, actually putting these rules in application with some problems out of the book. What I want to do now is I want to go ahead and start talking about a couple of problems from the book. These are found on, this is sum of number 1 on page 32. And so number 1 is divided into several letters all the way A through M. So let's get through A through G here. Now here, we're dealing with both ands and ifs. So they're combined here. So previously up to this point in this video, I've talked only about ands. And we talked about ifs and thens, arrows before in the previous section. Here we're going to kind of combine our skills together and see how they work. All our stuff still needs to be dyadic, where it's 2-ish, and so some parentheses are going to become involved here, and we're going to figure out what to do with that as we go through it. Let's take a look at the first one, 1A. It says this: sometimes I wake up grumpy, and, so that means, hey, there's a dot. Let's go and stick that in there. And sometimes I let him sleep. Now this one gives us a glossary. That is to say, it says, here's the letters that we use. W stands for sometimes I wake up grumpy, and S stands for sometimes I let grumpy sleep. When we see that those things are there, there's just a and between them. So what this one is, it's W, sometimes I wake up grumpy, and sometimes I let grumpy sleep. So it's W.S. Now, like I said, there's a sense in which this is equal to S.W, but that's not the order in which it was given. So I'm going to, even when I'm doing dots, even though there's a sense in which that's logically equivalent, we can make a little proof of how to break it apart and stick it back together and make it that way. I'm just going to do it in the order that it comes. B. Drink provokes the desire, but takes away the performance. That's from the porter in Macbeth. That but is a dot. And what's the first thing? We got drink provokes the desire. So P here stands for drink provokes the desire, but it takes away the performance. All that is represented by letter T. So we got P.T. Drink provokes the desire, but it takes away the performance. Again, that but means the same thing as and. C. I don't like this one, but I'm gonna say why I would translate it the way that it does. Notice here's something that you may have been told in elementary school. Oh, here is a sentence that starts with and. You're not supposed to do that. It's grammatically fine. But I'm going to say that what that means is I'm going to go ahead and put the dot here, and whatever comes after that one, I'm going to stick it right to the right. So it says, and although he was a very small ghost, Georgie had a really big idea. So I'm going to say here that is, and although he's a small ghost, which means the other thing goes on the other side. Okay, he had a big idea, although he was a small ghost. Okay, now this one I would accept S.B just as it is, even though, yeah, that's logically equivalent, just because of the order here that it's presented in the book is a bit sloppy. But this is, I'd say this is B.S. D. Erythricare is warming yet odor-free. Ugh. Well, that yet means there's a dot. What's the first thing we got? Erythricare is warming, yet, which means the same thing as and, it's odor-free. It is odor-free, it's just represented by O. So we got W.O. E. Let the people know the facts, and the country will be saved. I don't like this one either. And I'm going to go ahead and put a little, just a mark next to it. Okay, put a little star next to it. I don't like this one because I'm going to just put here what it is. It says this: let the people know the facts, and the country will be saved. Here's what it is. K-E-Y. arrow S. Now, I'm not going to give you one like this, but I want you to know that they exist. You might be looking at that and going, there's no if and then in there. There's an and. So sometimes things that look like conjunctions are actually conditionals. And you might be thinking at this point, how on earth would I possibly know that? Well, looking right at it, it's not clear. But I want you to know that what that quote from Lincoln is actually saying is, if the people know the facts, then the country will be saved. That's actually what's being said, even though it doesn't look like it's saying that. That's what it is. I'm not going to give you one like this, but I simply want you to know that it exists. So look out for it in case you see it. That's actually an if-then statement. So he's saying then we could do a modus ponens there. Okay, if people know the facts, then the country will be saved. People know the facts. Hey, the country's going to be saved. Okay, if the people know the facts. Okay, that's really what's going on there. It's not one of those things. It's not actually a conjunction, even though it looks like one, which is a bit of an antiquated construction, but it's possible. F. I may be fat, but you're ugly, and I can diet. So I'm just going to start translating that one exactly as it is. Okay, I may be fat, but that's a dot. You're ugly. And that's a dot too. I can diet. So F.U.D. Is this done? Nope. It's not dyadic. Okay, remember I said dyadic means regardless of what you got, whether you got an arrow or you got a dot at this point, either one of these, it's got to be two-ish. You got to have a left side and a right side. This one does not have that. It has three sides. What this means, we need to put one of two things here. Either we need to put F.U parentheses dot D, and this would be the heavy left version, or we need to put F.U.D, and this would be the heavy right version. So which one of these is it? Well, here's the trick with ands. Now, this is not true with arrows, but with ands. If it's all ands, and this one is, we got a dot, 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 it doesn't matter what order you put the parentheses in. It's got to be one of these two. You can't just go, like, around the whole thing, F.U.D. Well, it's got parentheses, I put around the whole thing. No. Not that. It's got to be one of these. So here, we've got a heavy left side and a tiny right, or we can get a tiny left side and a heavy right. Either one of these are fine, but it's got to be one of these. It's got to have parentheses to make it dyadic. And like I said, if it's all ands, it doesn't matter where the parentheses go. It doesn't change the meaning at all. Not true if it's all arrows, and not true if we have things where we have arrows and ands mixed and matched, which we haven't encountered yet, but that's going to come up here in just a moment. All right, finally, let's get to letter G. Letter G is a bit different, too. It's something we have not encountered yet. It says this: you can fool all the people all the time. Yeah, that's just F by itself so far. If, oh no, this is not an and, this is an if, which means there's an arrow here. So I'm going to go ahead and stick because I don't know how much space I'm going to need yet. I'm just going to go ahead and write an arrow. And remember, whatever follows if goes on the left side of the arrow. Whatever follows if goes on the left side of the arrow. So what do we have following if? You notice there's two things. It says, if the advertising is right, advertising is right is A, and the budget is big enough. If the advertising is right and the budget is big enough, then what? Oh, then you can fool people all the time. So that means there's two things together on the left side of the arrow. In fact, it told us, like here you got a dot, so we actually know it's going to be a heavy left. Like all this stuff is together. There's a dot. If the advertising is right and the budget is big enough, you've got that, then what? You can fool all the people. So if it's the other way around, like let's say if I put the parentheses in another spot, let's just examine what that would look like. If I had A dot B arrow F, like what would this one say? So let me be clear, this one is not correct, and here's why. Here's what it would say. This one says, the advertising is right, and if the budget is big enough, you can fool all the people all the time. So this thing here is floating by itself. The advertising is right. That doesn't make any sense. So that's why this one doesn't work. And think about it. What this one's saying, if it's saying, if the advertising is right and the budget is big enough, you can fool people all the time. So think about this. This works into like a arrow out kind of thing. So if I had these two things, if I had the two things, I've got the right advertising, I got a big enough budget, well, using our arrow out powers, then we could figure out, oh, then you can fool people all the time. But what if I only had one of them? Oh, I've got, let's say the advertising is right and the budget is big enough. Oh, I have a budget that's big enough. Well, sorry, friend, you've only got half the requirements you need in order to fool all the people all the time. You need this other thing too. You need them together. You've only got one. Sorry. This is what happens if you ever filled out like an I-9 form and you're like, oh, you need your driver's license and your social security card or a passport. You need items from column B and one item from column B, one item from column C, or you could have only one from A. That's a logic problem. And you show up with your driver's license. Oh, we also need another form to confirm identity. Stuff like that. Oh, well, I only brought my driver's license. Sorry. We can't help you, friend. That's what's going on here in this kind of a situation. So again, we know it's a heavy left based on the construction that it has, because what follows if is an and statement. So we know all of the and statement goes on the left side of the arrow. Okay, let's take a look at the next few here. They're going to get a little bit more sophisticated as we go along. Let's take a look at the next wave of number 1 here. So this is still on page 32 entirely. I'm not going to do letter M. So let's take a look at these. H. It's my party, and I'll cry if I want to. You'd cry too if it happened to you. Let's take a look at this one. So it's my party, and I'll cry if I want to. So it's my party, and if I want to, then I'll cry. That's it. All right, so parentheses on the right. If I want to, then I'll cry, and it's my party. All right, when I put it that way. Now, if it's the other way, if I say like this, it's my party, and I want to, then I'll cry. That's not what's being said. It said, it's my party, and I'll cry if I want to. Notice, that's there for no reason. Should, now remember, should is a word that also means if. So that means there's an arrow. And just think of the word should as the same thing as the word if. So whatever follows if, or in this case, whatever follows should, goes on the left side of the arrow. So what do we got? Should the Missouri River waters start flowing over the main road? Comma. Now that comma means the then is there. So that means if it's should the Missouri River waters start flowing over the main road, we got an F on the left side of the arrow. So if it starts flowing over the main road, then this next stuff. What's left? Campers will be required to leave, and the park will be closed. So if the water starts overflowing, both of these things are going to happen. It's not here, but sometimes the word both also lets you know that a conjunction is coming. Like here's a dot that belongs together that you can stick in parentheses. The parentheses are required to make it dyadic. Now it's not here, but it could be. So watch out for that word both. It lets you know, hey, these two things go together with a dot. That's that one. Like I said, this one would end up saying, if the waters start overflowing, then campers will have to leave. That makes sense. But then also for free over here, oh, and the park will be closed. No relation to what's going on over here. That doesn't make any sense. This is all contingent on the waters overflowing. J, if I make an out, I lose. Now because of that I there, it looks like it's all yelling, all uppercase. But here's what's going on. If I make an out, then I lose the batting championship. And if I get a hit, then I win. So here's what it is. Now this one's a little bit tricky. It says if I make an out, then I lose. And if I make a hit, then I win. So that's translating as it is. Is this dyadic? That is it two-ish? Not at all. So where do the parentheses go? Because that'll change the meaning. Now we got a couple options here. The clearest one is that, okay, here's an and statement joining two different arrows. So if I read this back, this sounds exactly like it should be. If I make an out, then I lose. And if I make a hit, then I win. Now we actually have other options, but I don't think I want to get into at this point. Like I could say something like, here's something that would be logically legitimate. O arrow, L dot, H and W. You're like, well, what are these brackets, professor? Well, brackets are just super parentheses. So this is dyadic. Look, I got a tiny left and a hefty right. It's extra hefty. And then inside the hefty right side, I've got a tiny left and a hefty right. This is dyadic. This is not what is said here. This says, if I make an out, then all of the following. I lose, and if I hit, then I win. So this is saying, if he makes an out, then all this is true. And that's just stupid talk. So no, it's what we already had. It's, if I make an out, then I lose, and if I make a hit, then I win. Dyadic. Look, left, right, good to go. So this statement is actually a conjunction. Oh, but it's got arrows in it. It's an if-then statement. Nope. It's a conjunction of two conditional statements. K says, if he arrives, and if he is the new boss, I will obey him. Two ifs in there. Are there two arrows? Surprisingly, no. So this one's a little bit tricky as it is. And like I said, the book stuff is a little bit trickier than what I'll give you on quizzes, I think. Because I think sometimes the author of your textbook goes out of his way to kind of trip you up. But no, there's two ifs, so it seems like there's two arrows. No, there's actually one arrow. It's just there's two things on the left side of the arrow. What two things? And I know this because there's an and hiding in there. It says this: if he arrives, and so if he arrives, that's on the left side of the arrow. And if, oh, this thing's also on the left side of the arrow. And he's the new boss. So what it's saying is this is a team effort here. If he arrives and he's the new boss, or if he arrives and if he's the new boss, all this stuff is on the left side of the arrow. If all this stuff happens, then I will obey him. So it's kind of like we were saying earlier about this one with the flooding. Let's take a look if we had this just briefly as like an arrow out kind of thing. Like, oh, if he arrives and he's the new boss, I will obey him. Oh, well, he's arrived. Does that mean I get to obey him? No, because it's not demonstrated that he's the new boss. Or, oh, he's the new boss. Then I must obey him. No, not a left side match. He hasn't arrived. So I'm not going to obey him yet if he hasn't shown up. If I made an arrow out problem out of that one. L looks difficult. It already if you just look at it, it looks like it's a bunch of words. I suppose all of these are. But this one already sounds obtuse. But this is actually where formal logic is helpful. This is actually a logician, James Carney, talking about logic. And so automatically you hear, if you hear this, if one can show that the axioms of System 1 can be interpreted so as to be theorems of System 2, and that System 2 has the same inference rules as System 1, then System 1 must be consistent if System 2 is consistent. And already you might have, about halfway through that, just been like, nope, I give up. Formal logic actually makes this easier. Just go through it a little bit at a time. Okay, and this is where formal logic is helpful to follow an argument. So even when people are dealing with stuff like technically like we don't understand, we can still follow what's going on if we track it with the formal logic. So far we've been doing things that are fairly simple that really anyone could grasp. But this is where people can lead us astray, is by saying technical things and us going, if you say so. Let's take a look at what's going on here. So the first word we see is if. That means already there's going to be an arrow happening. However much stuff is to the left of it or to the right, and I'm going to give myself a little bit more space just in case I need it, because I know this is a bigger problem. If one can show that the axioms of System 1 can be interpreted so as to be theorems of System 2, all that is just I. So it says, that's it. All right? All that stuff there. All of this, one can show that the axioms of System 1 can be interpreted so as to be theorems of System 2. All of that is just I. And the next word is and. That's a dot. And it says this, that System 2 has the same inference rules as System 1. Well, all that's just R. And then we see the word then. Now, what that means is everything that just happened followed the if, and it's before the then, which means all this stuff together is on the left side of the arrow. It's all a package deal. If this and this, then what else is happening? Then everything else is on the right side of the arrow. And it says this, then System 1 must be consistent if System 2 is consistent, which means on the right side of this arrow is another arrow. And for that arrow, whatever follows if goes on the left side. So what follows if? Actually, what follows, it's in a little bit of a different order. It says System 1 must be consistent if System 2 is consistent. So the whole System 2 is consistent is actually on the left side of this arrow. That's T. And well, that means then System 1 is consistent. And this, since it's following the right side of the arrow, this is a package deal. Really what this is saying is, if both these things are true, then if this thing, then that thing. So even if you don't understand the technical minutia of what's going on, what you see right now in front of you, that's the structure of what's going on. If these two things happen, then this other thing happens, then O is going to happen. That's all that's being said. I'll repeat that one more time. If these two things happen here, you got I and R, then hey, if you got T, you got O. Where would this be applied in something that might make more sense? Well, consider, like, let's say the United States Constitution, Article 2, 35 years old, and you're a naturally born citizen, then, hey, if you're elected, well, then you can be the president. Okay, well, I'm 35 years old. Well, cool. Are you also a naturally born citizen? No? Well, then this other stuff isn't happening. Well, hey, I'm 35 years old, and I'm a naturally born citizen. Okay, if you got that criteria, that's great. Were you elected president? No? Well, then it's not going to happen. Okay, that would be the same, it's the exact same, that condition in the Constitution is the exact same logical structure as this. You got these two criteria? Great. If you got those, then do you have this one? Yes? Well, then great, you got it. You win, yay. Then you don't get it? No, you don't move on. So what we'll be doing next is we'll be taking a look at the problems of number 3. Let's take a look at problem 3A. This is page 33 in the book. Now, the way that it's got it is a little bit weird, but I'm going to give it to you as I would give it to you if you had it on a quiz. So here's what we've got. We've got one assumption, A, and he uses ampersands for ands. I'm going to use dots. We've got A dot B dot C. This is your one and only assumption. This is what you're given. And it says solve for this. Get A dot C. Okay, I'm going to remind you, we got 3 rules that we can use. We got arrow out. That's where if you got an arrow and you get a left side match, you can get the right side. We've got and out. That's where if you got dots, you can break them apart. And if you've got two, and then we've got and in, which is if you got 2 separate things, you can bring them together. And I'll say this, with all these problems, you should think about it in this way. With arrow out, can I do this? If so, do it. With and out, next you should move on. Can I do this? If so, do it. And then with and in, you should think, should I do this? That is to say, if you have 2 things, you can always stick them together, but is it worth doing? Let's take a look at this. First of all, let's see if we can do this. Now remember, things in parentheses we can't get to yet. They're trapped. So let's take a look. Do we have any arrows not in parentheses? No. So we cannot do this, so we're going to move on. The next thing we want to look for is, do we have any dots, any ands, not in parentheses? Well, yeah, we got this. This is not in parentheses. So this means if you got a dot not in parentheses, you can do this. You can just break them apart. And so that's going to get us 2 things. It's going to get us this thing and this thing. And here, when we break it apart, this thing is going to get freed from its parentheses. So we're able to get 2 things. We're able to get just A and B, now freed from its parentheses, and we're going to say how we did that. Well, we used and out. Where was our source material? Line 1. And we can also get just C by itself. Okay, that was the other side of this. What move did we do? And out. Also line 1. Okay, great. The move is done. Now, let's go ahead and as we move on, what we want to do is go back to the top of this list. Now, hopefully you can see there's no arrows here, so this is not going to happen. But just to be consistent, I'm going to say, all right, let's try this again. Can we do an arrow out? Do we have any arrows not in parentheses? Nope. Okay, do we have any dots not in parentheses now? Yeah, we got this new one here. This one's not in parentheses. What are we going to do? Break it apart. And we get 2 things. We get A by itself, and we say, how do we do that? And out. Where's the source material? Line 2. And we also get B. How do we do it? And out. Where was the source material? Also line 2. Okay, now, next thing. Go back to the top of the list. Can I do an arrow out? Nope, no arrows. Second thing, and out. Do I have any dots that I can slash apart in half? That one's been done, that one's been done, there's no more left. So the next question becomes, should I put anything together? Now we can put any 2 things together that we want. Now just because we can doesn't mean that we should. For example, right now I could say, oh, B dot A. And in 5 and 4. I could totally say that. It's fine, perfectly legitimate, perfectly valid even. Is there any reason to do that? No. None whatsoever. In fact, when you get to this point where you're like, okay, I've gotten all the arrows out that I can, I've broken apart all the dots that I can, what you want to ask is, at this point, is there anything that I should build? And so here's the deal. At this point, remember, here's what we're trying to solve for. We're trying to get A dot C. And so at this point, like you've done all these that you can do, you've done all these that you can do, look and see, is there anything that I should build? And if, I'll say this, if you're trying to solve for a dot, 99% likelihood that what you're going to do is you're going to take these 2 pieces and stick them together. So let's look for, do we have this piece by itself somewhere? Yep, line 4. Do we have this piece by itself somewhere? Yep, line 3. So guess what? All we got to do is put those 2 pieces together and we'll have exactly what we're searching for. So check it out. A dot C. How do we get that? And in, adjunction, where's the source material? So where was that A come from? 4. Where's the C come from? 3. Now this problem's done. Like, we did it. We got the thing we were setting out to get, and we cited all the reasons of how we got it. In a certain sense, this B that we got in line 5 is completely superfluous. We got it out, but we don't need it for any reason. Like, we didn't use it later on. Sometimes you'll see that you won't need something, and you might choose to say, oh, I don't even need to bother saying it. For now, I'm just going to say, just break everything out that you can, because it might happen later on that you don't realize that you're going to need something later, and you think, oh, I don't need this, I don't need to get it out. But you do, and you need to use it later. So I'm just going to say, if you can break something out, even though this line 5, like we never use line 5 ever, go ahead and break it out anyway, because it might come in handy later, even if you don't know that. let's look now at 3b. This one's got two assumptions. We've got A dot C, assumption number 1, and then we've also got just B by itself, assumption number 2. And then it tells us, oh, here's what you want to get. You want to get this. A dot B with A and B in parentheses dot C. That's what we want. Now you might be thinking, well, can't I just jam that in there? If I'm going to get A dot B dot C, can I just jam the B in there? Nope. That's, if we look at our rules that we got arrow out, which is, again, you got an arrow, your left side match, you get the right side match. That doesn't really apply here. This one, and out. The way this one works, and out. You got a dot, you can separate them into the different pieces, and then you got and in, which says if you got two separate pieces, you can stick them together. There's no way to just jam that B in there and get what we want. It's not a thing. So what we got to do is we got to do it with the rules that we've got. So first of all, I said look at this. Think of this as like, can I do this? Can I do this? Should I do this one? All right, let's try it. So first of all, do I have any arrows here not in parentheses? Nope, can't do that. Moving on. Do I have any dots not in parentheses? I do. This one right here. So let's break it apart. This breaks down into its two separate components. We get A and C separately. And out. Where's our source material? Line 1. Same thing here. And out. Also line 1. So we broke it apart. All right, now, next move. Any arrows to break apart? There are no arrows. Any more dots to break apart? Nope. So then we're faced with this. Should we build anything? We know that we're going to want A dot B dot C. So we're going to build the pieces of this to make it. So first of all, we need to build A dot B, and then we're going to adjoin C to it. So let's make the first thing that we need. Can we make it? We sure can. A dot B. That is half of what we need. Where do those pieces come from? Well, A came from 3, B came from 2. So that one's done. So then we're going to take this and we're going to mix this with C, because we can't do an arrow out. We can't do another. I mean, we could break this apart. We could, but it would just get us pieces that we already have. So there's no reason to. So this is, we're building this on purpose. So then we can take this and adjoin it or combine it with C. And it looks like this. We're taking this thing and adjoining this onto it. How did we get that? We're ending in these pieces. Where was A and B? Line 5. Where was C? Line 4. And that's the exact thing. That's the exact thing we were trying to solve for. So there it is. This problem is done. Now let's take a look at 3C. So I'm going to give 3C to you as I would give it to you if you were ever giving it to you on a quiz. So this one's a little bit more complex. So here's what we got. Line 1. D dot E. Assumption. Line 2. D arrow F dot E arrow G. This is also an assumption. And then I'm going to say we're solving for this. Get this. This is the mission. You get this thing, you're done. F dot G. Okay, get that, we're done. Okay, now as a reminder, here's the 3 moves that we've got. And we're actually going to have to use all of them in this one. We've got 3 moves. First of all, we got arrow out. And the question is going to be, can I do this one? Okay, so here's the way it works. You got an arrow, you got a left side match. You can totally get the right side. Okay, then we got and out. Can you do this one? Do you have a dot somewhere? Break its pieces apart. And then the third move is and in. And this is a should. And I'll explain what I mean by that here again in a moment. So this one says you got 2 pieces. Any 2 pieces, you can always put them together with a dot in any order. Like instead, I could put B dot A. That'd be fine if I needed to and if I wanted to. So first of all, like here, right now, and in always says you got 2 things you can put them together. So right now I could say in line 3, oh, D dot E, and brackets are nothing more than super parentheses. I could see like, oh, and in here, D arrow F and E arrow G. And in lines 1 and 2. Is this a legitimate move? Yeah, Should you do it? No. It's a waste of time. That's why you should always go to the top of this list. Okay, always go to the top of the list. And see, alright, can I do this one? Then can I do this one? Then should I do this one? That should always be the order. So start with this. Okay, do I have any arrows not in parentheses? No, I don't. I have two arrows. There's D arrow F and there's E arrow G. They're in parentheses. These are locked. I like to think of it like I play a lot of video games, so I think of this, it's like, you know, like in Zelda. No, you need the big key in order to get to these. Like, they're there they are. Alright, you need some special item to unlock this. You defeat the boss first before you can go into this room, all that kind of stuff. Works that way. Like, no, I can't get to these. There they are. Okay, and oh, look, and even there's the F and the G that I need hiding right there. But I can't get to them yet, at least with the arrow, because I don't have an arrow by itself, and I don't have left side matches, so none of that stuff applies. So can I do this one? No. So I move on. Do I have any dots not in parentheses? Yeah. In fact, I've got two. I've got this one, and I've got this one. Okay, so I've got two that I can break apart. I can do this on either one of these. I can do it on line 1, I can do it on line 2. Which one am I supposed to do first? I'll say this, in formal logic, it doesn't matter. If you can do a thing, it doesn't matter the order in which you do a thing, as long as you can. So here, I like to do things in the order that they come first, so I'm going to do line 1 before I do line 2, but if you broke apart line 2 before line 1, that's just as correct. So let's start with line 1. What does it break apart into? It gives me two pieces, D and E, because you just take the dot, you get rid of it, and take the two pieces and break them apart. And then what you do is you say what you did. That was and out. Where was the source material? Line 1. Same thing for this one. This one was also and out on line 1. Okay, now I did a move. Every time you do a move, go back to the top. Do I have arrows not in parentheses now? No, that hasn't changed. Okay, but I also know there's this other dot I could slice apart here. So I'm going to go ahead and slice that apart too. That gives me lines 5 and 6. Okay, so we get D arrow F. Now freed from the parentheses because it's no longer adjoined to this thing. And I get E arrow G separately. Both of those are and out on line 2, because that's the move that we're doing, and the source material was in line 2. That's where it came from. Okay, now, go back to the top of the list. Can I do an arrow out now? So first of all, do I have any arrows not in parentheses? Yeah, I got two. I got this one, and I got this one. Now, do I have a left side match for this one? Yes, I do. Do I have a left side match for this one? Yes, I do. So which one do I need to work with first? Which set? It doesn't matter. I just said that. Like, in logic, as long as you can do something, then you can do it. It doesn't matter the order, as long as you can. So, like I said, I like to do things that come first, okay? But it wouldn't be wrong to do it otherwise. So let's do that here. We got this arrow, okay? Its left side is D. I got a left side match for it, which means based on this rule, right, there it is. You got an arrow, you got a left side match that unlocks the right side by itself. So let's take a look. I got D arrow F. I got the left side D, which means I unlock F. I'm going to say here in line 7, hey, I get F. How'd I do that? All through the magic of arrow out. Now then I'm going to cite my sources. Like, where did I get these pieces? Where was the arrow that I used? Well, the arrow that I used was in line 5. Okay. Where was its left side match? Oh, its left side match was in line 3. So that's where that came from. Okay, that one's done. Now I would say go back to the top of the list, but we already know that there's this E arrow G and E to work with. So let's work with them. So that gets us, okay, we got an arrow here. Its left side is E. We got a left side match here, which means we can unlock G. So let's get that G. What did we do? What move here? Arrow out. Okay, where was the arrow that we got this from? Well, the original arrow that we just used was in line 6. Its left side is E. Where was its left side match? Line 4. So we're going to say 4. So that's good. All right. So look, now we finished a move. Let's go back to the top of the list. Any new arrows not in parentheses? Nope. We've taken care of all those. Any dots not in parentheses? Nope. We've taken care of all those. So everything's been broken down. Like all the letters that were here in the beginning, we actually now have all of them by themselves. Like all the individual pieces. We've broken everything down. Okay, it's not like we took a Lego set and took everything apart. Okay, so now, can I do this? I already said no. Can we do this? Also, no. Should I build anything? Now, two things. One, we can take any of these 8 parts and slap them together. Any of them. We can do that, but notice that's why I didn't say can. Should we put things together? Well, remember, the thing that we're trying to get here is this, F.G. And like I said, if you're trying to get a dot, there's a 99% likelihood. I could think of some exceptions, but I just want to I want this to become a habit here. If you're trying to get a dot, look and see, do I have this piece by itself? Do I have this piece by itself? If you do, if you have these pieces by themselves, do this move. Just put them together. Do we have those pieces? Do we have F? Yeah, line 7. Do we have G? Yeah, line 8. So what do we do? Line 9? Just slap them together. F dot G. What move did we do there? We stuck an and in there. And then we just say, where do we get the pieces from? Oh, F came from line 7. G came from line 8. There it is. It's done. And here, actually, we used all 3 of these moves. Okay, we have a bunch of and outs, a couple of arrow outs, and our final finishing blow was an and in. Now let's take a look at number 3D. So first of all, line number 1, we got H dot I, arrow, J dot K. That is assumption numero uno. Then we've got line 2, just I dot H. That's assumption number 2. And then we've got from there, we're solving for this. We are solving for just J by itself. Okay, great. Now, as a reminder, we have these 3 moves in place. We got arrow out, which the question is can I do it? Do you have an arrow? Do you have a left side match? Well, then get the right side. Then we got and out. The question there is can. You got 2 things together with a dot, break them apart. Okay? And then we've got the third move that we've got, at least right now, which is and in, and it works this way. Do you have 2 pieces? Stick them together if you should. Not necessarily if you can. Just because you can doesn't mean it's going to get you anywhere. And again, maybe you could put them together in an order that you may not expect. Alright, so let's do that here. So first of all, what we want to look for, and so this is the way to go through these problems. Okay, first of all, do I have any arrows not in parentheses? Yes, I do. Right here. Now, I have an arrow not in parentheses. Now look at its left side. Its left side is H dot I. Do I have a left side match? You might think here, this looks pretty close. That's I dot H. It's the same. It's basically the same thing. Does this unlock it? No. No, it doesn't. It's very similar. In fact, it's logically equivalent. It does not unlock this. Okay. And the analogy here, it's kind of like you've got the right key, but you've got the key and you're inserting it upside down. Or this reminds me of, have you ever inserted something in a USB? Like, I don't know about you. Every time I've ever taken a USB and tried to put it in a computer, the first time it doesn't work, so I flip it over and that doesn't work. But then I flip it over again, and finally somehow the third time it works. Kind of what's going on here. Like, you got the right thing and you got the right pieces. It's like your key's upside down. Okay, so you got the right pieces, but the key's upside. It doesn't fit exactly right because the key's not going to fit upside down. So just for now, for simplicity's sake, I'll just say, no, we don't have this. We can't unlock this because we don't have it exactly. It has to be exact. Do we have that? No. So we move on. Do we have any dots not in parentheses? Now we got 3 dots here, here, and here. Are there any not in parentheses? This one, not in parentheses. So what are we going to do? Break it to bits. So break it down. We get line 3 and 4. Its parts, I, H. What we did there? And out for both. And we broke that down from line 2. Okay? Any arrows to break apart? No. Any ands to slice in half? No, we just did that. Anything we should build? Yeah. Right. Now we literally have the pieces broken down to build this left side that we do need. So it's not that the goal here in the end is an and that we need to build, but the thing we need right now. We want to unlock this arrow. Like, there's that J right there. That J that we need is right there. But in order to get to that, we have to unlock this. Do we have the pieces to build this? Right here. So let's build it in the right order. And like I said, this is the equivalent of taking the key that we have upside down out and just turning it over. So let's build H dot I. What move did we do there? And in. Where were the pieces? 4 and 3. So again, we kind of just turned line 2 over. Now later on, there is a move that we'll learn that allows us to just flip these immediately. That's the commutative property, but we don't know it yet. Or you don't know it yet. So now we got H.I. We just built it. All right. Now go back to the top. Do I have any arrows? Not in parentheses. This has been true since the beginning. Do I have a left side match now? Yeah, I do. What does that do? It unlocks J dot K, not in parentheses. What move did we do there? Arrow out. Where was the arrow that we used? It's the arrow that's been sitting there since line 1. Okay, where was the left side match that we built? Line 5. Okay, great. Do I have another arrow now? Go back to the top of the list. Do I have another arrow that I can... It's not in parentheses, for which I have a left side match. Neither of those. No. Do I have any dots that are new that I can slice apart? Right here. There it is. So what are we going to do? We're going to slice this apart. We get 2 pieces. J and K. Where did we get those pieces from? We did and out on line 6. And we did and out on line 6 as well. Now wait a minute. What were we trying to get? J. Did we get J? Yeah. Once we got this, we're done. And what about this K here? It's just extra. It's like the packaging. Like when you get something and you get the packaging and you throw it away. Like this is here. You don't need to get rid of it. It's not wrong. Now, if you realize that you don't need it, you could toss it away. All right. You don't even have to do line 8 at all. But we did the job and we have all the pieces that are accounted for. So if you did this, like yeah, solve for J, we did. All right. Here's a bit of leftovers. This is kind of like the remainder. If you remember doing like long division, this is fine. You don't need to get rid of this. Okay. In fact, I encourage you to go ahead and, like, if you can break something down, go ahead and break down all the pieces. You might recognize, oh, I don't need this, so I completely don't even put this in here at all. Oh, that's right. That's true. You don't need this, and you don't have to put it here, and this is just as correct. But if you're not sure, go ahead and just break it all down. As long as you get what you need, you're golden. So now, let's take a look at the next set of problems here. On the bottom of page 33, we're combining skills. So here, for the last few minutes, we've been doing just these 3 A, B, C, D problems, where we're just looking at the formal logic and trying to work through it. And before that, we were doing a couple of translations. Starting with number 4, we're going to do ones where it's kind of both put together. All right, they synthesize. We're translating things, and we're solving for the proof as well. Number 4, this is on page 33. It says this. I fed the big fish. What would that be? Line 1, that's just B. Assumption. Line 2. If I fed the big ones, so arrow, if I fed the big ones, then I fed the little fish. Assumption number 2. Thus, so here's what we're solving for. I fed both. That means, oh, here an and is coming. I fed both my big fish and the little ones. Okay, that's what we're solving for. And so remember, we have 3 things that we can use. I'm going to do it a little bit in shorthand this time. So we've got 3 moves that we can use. We can use arrow out, we can use and out, and we can use and in. And we want to say, can we do this one? If not, can we do this one? And then finally, should we do this one? So let's go through it. So first of all, do I have any arrows not in parentheses? Yep, here. So I have an arrow not in parentheses. Do I have a left side match? Yes, I do. That means I unlock L. That's arrow out. Where was the arrow that I used? Line 2, where was the left side match? Line 1. And then I want to do this. After I do a move, can I do another arrow out? Is there another arrow not in parentheses? No. Is there a dot not in parentheses? No. So then the question becomes, should I make an and in? And like I said, look at the goal. The goal here that we're trying to get is B dot L. And I said 99% of the time, if you're trying to get an and, you're probably going to build it with an and in. So do I have the pieces to build this? Do I have a B somewhere? Yep, line 1. Do I have an L somewhere? Yep, line 3. So let's just put them together. B dot L, which is what we want to get, and in. Where was the B? Line 1. Where was the L? Line 3. And this one now is done. Number 5 says this. I fed the big fish. But it's not done. And if I fed the big fish, I fed all my fish. Hence, I fed all my fish. Now, the way the author of your textbook does it here is he only capitalizes some things at certain times. I'm going to kind of give you this one as it should be. I'm never going to uncapitalize something when it is repeated like the author of your textbook does. Line 1 would be this: I fed the big fish, and if I fed the big fish, then I fed all my fish. Assumption number 1, in fact the only assumption that says hence, that means this is what you're solving for. I solved for this. I fed all my fish. Just A by itself. Okay, we got 3 moves in place. Arrow out, and in. The questions are, can I? If so, do it. Can I? If so, do it. Should I? If so, do it. Okay, first of all, do I have any arrows not in parentheses? I have an arrow, but it's parentheses, so I can't do anything with it yet. Do I have any dots not in parentheses? Yep, right here. So what can I do with that? Break it apart. That gets me 2 things. I'm going to get B by itself, B, and out. Where did that come from? Line 1. And then this B arrow A here, I'm going to get, and it's going to be unlocked from its parentheses now. I also got that, and out, line 1. Okay, move is done. Go back to the top of the list. Do I have any arrows not in parentheses? Yep, now I do. Line 3. The left side is B. Do I have a left side match? I do. So that unlocks A. And that's actually what I wanted to get in the first place. Which means once I get this, I'm done. So I just say what I did. I did arrow out there. Where was the arrow? Line 3. Where was the left side match? Line 2. Problem is done. Number 6 is actually a classical argument from philosophy, namely Metaphysics, Book 12 by Aristotle. But let's look how it's broken down for us here. So there's the original argument as W.T. Jones breaks it down. And then let's take a look at what is actually said in the second part, where on page 34 it says Jones's argument, and he's breaking down Aristotle's argument from Metaphysics, Book 12. So even if we don't understand the parts, let's actually see what it says and just represent it formally. The unmoved mover knows only the best. That's simple. No ands or ifs in there. That's just K. K, assumption. Line number 2. The unmoved mover is the best. And the unmoved mover would be God here. That's an assumption. And then it says this. Okay, those 2 so far are easy. It says if the unmoved mover knows only the best and is the best. So it says if, which means we know there's going to be an arrow. And whatever follows if goes on the left side of the arrow. So it says if he knows the best and is the best. All of that is on the left side of the arrow. If both those things are true, then he knows only himself. Or itself for Aristotle, but that's what it says here. So unmoved mover knows the best. Unmoved mover is the best. If he knows the best and is the best, then he knows only himself because he's God, according to Aristotle and Jones here. So what we're going to solve for is this, because it says, so the unmoved mover knows only himself. Which is to say, for Aristotle, God only cares about himself, in the sense of that's all he knows. Okay. Many philosophers throughout history, Aristotle, Thomas Aquinas, Maimonides, Ibn Rushd, have pondered this question. But here's at least what Aristotle says, and here's his argument. Basically, God only knows himself, and maybe if he knows other things, he knows them in relation to himself. That's another argument altogether. But we've got this argument. We want to solve for H. God only knows himself. And we've got these 3 moves in place. Arrow out, and in. And again, the question is, can I do this one? Can I do this one? Should I do this one? All right, let's give it a shot. So first of all, do I have any arrows not in parentheses? Yep, right here. Okay. The left side is K dot I. Do I have that as a match? I've got K, there's I. Do I have a match to this K dot I? I do not. Moving on, next one. Do I have any dots I can break apart? Do I have any dots not in parentheses? Oh, there's a dot. It's in parentheses. So can I break it down? No. Next question. Should I build anything together? Now, I can take any of these 3 things and put them together. As long as you got 2 things, you can always put them together. Is there anything I should put together? Now, look, our goal in the end is H. It's not a dot. but is there anything I should build right now? Like, so look, so if your goal is not a dot, is there anything else that you should be looking for that's a goal in the moment that's a dot? So right now, for example, if we had k dot I, we could get h, which is what we want to get. So do we have k dot I anywhere? No. But do we have the pieces to build k dot I? Yeah, we do. So let's do that. We should do that here. So we can build k dot I because we got the pieces in 1 and 2. And in fact, I'm going to say and in. Where do those pieces come from? 1 and 2. Now, go back to the top of the list. Can I do an arrow out? Do I have an arrow? It's been there. Its left side is k dot I. Do I have a left side match? I just built it. So what does that mean? I can unlock the right side of that arrow, H, arrow out. The arrow is in line 3. The left side match was in line 4. And I got exactly what I wanted to get. And I said how I got it. Let's take a look at number 7. Okay, the first thing it says is the prisoner contracted hepatitis in jail. Now, you might want to go ahead and say, oh, number 1C assumption. However, it says, this is a consequence of the following facts. Now, that there means, now this is confusing, all right, and I wouldn't give it to you this way. That means this is actually the thing, if it's a consequence of the following facts, the prisoner contracted hepatitis in jail, which would just be C, which, by the way, gross. That's actually the conclusion. That's what we're solving for. It's not clear there, but that's what we are. That's what we're doing. So when it says this is a consequence of the following fact, it's saying this thing here follows from the following facts. So the following facts are the assumptions. Let's take a look at the facts. Line 1. The incubation period for the disease is from 10 to 50 days. That would be I so far. But it keeps going, yet, that means and, yet the prisoner has been in jail for more than 4 months. Okay, F. That's our first assumption. Line 2. We stop with a period. Each period means we're on to the next line. It says, now, that now is just there for free. If the incubation period is from 10 to 50 days, so that I already had, if that, then if. Alright, it says then if. Remember, when we see then if, it says then provided that, but then provided means if. So remember, we see if then if, that means we got a heavy right, and we know another if is going in here, another arrow is going in here. That's going to be an assumption. What follows provided that then? The man has been in jail for over 4 months. If this, then if this, he must have contracted the illness in jail. These are the assumptions. These are the facts. This is what we're solving for. We've got 3 moves. Arrow out, and in. Again, can we? Can we? Should we? Let's do it. So first of all, do we have an arrow not in parentheses? Yes, we do. Right there. Do we have a left side match? Do we have I by itself? Oh, we have an I here. Is it by itself? No. Moving on. Can we do an and out? Do we have a dot somewhere not in parentheses by itself? We do. So what does that mean? We can break those 2 things down. That gets us I and F separately. What move there? And out, line 1. And out, line 1. Now, go back to the top of the list. Can I do an arrow out? Do I have an arrow not in parentheses? Yep, line 2, it's been there. Do I have a left side match? Yep, in line 3. That unlocks this right side, which is F, arrow C. It's bigger, but that's the right side of that arrow, and that's going to unlock it from the parentheses. So I get F, arrow C. Arrow out. Where was the arrow? Line 2. Where was the left side match? Line 3. There it is. Go back to the top of the list. Do I have any new arrows not in parentheses? Yeah, this one that we just got. Does it have a left side match? Line 4. What does that mean? I'm going to unlock C. Hey, that's the thing I wanted to get in the first place, which means once we prove this, we're done. So yeah, line 6 is C. What move did we do? Arrow out. Where was the arrow that we used? Line 5. Where was its left side match? Line 4. Done. Now number 8 says Roman reloaded. Here's the proof, which means we're solving for Roman reloaded. Okay, line number 1. Here's the proof. That's how we know it. Like here are the assumptions. Here are the facts that we want to use to solve this mystery that Roman reloaded. Let's prove it. His 9mm Beretta holds 17 bullets, and there were 5 live rounds in the weapon. Assumption number 1. Fact number 1. Line number 2. but, that word but there, yeah, it means and, but it's superfluous here. It's just there. Detectives found 13 spent casings. Fact number 2. Fact assumption number 3. Now, if the handgun holds 17 bullets, and the police recovered 13 spent casings, and there were 5 live rounds in the weapon, well, let's take that. We got this so far. It holds 17 bullets, and they recovered 13 spent casings, and there were 5 live rounds in the weapon, then Roman must have reloaded. No, okay. So all this stuff is on the left side of an arrow. Alright, great. For Roman reloaded. Assumption number 3. Is this dyadic? No, it's quadratic. There's a special kind of math for that. So let's take a look at this left side. Is it dyadic? So what that means is this stuff is going to have to be grouped together so that we make it dyadic. So first of all, the first level of grouping I use is parentheses. The second level I use is brackets, and then the third level I use is braces. If we go any more than that, I usually end up repeating. Okay? So that's what I use. Like, this is level 1, level 2, level 3. So here we got 3. This is definitely the left side. H.C.L, then R. So here's 3 things. So I know this. If I go 1 level out, I'm going to have this. Brackets around H.C.L. But if I zoom into here, is this dyadic? No. There are 3 things. Hey, but it's all dots in here, which means I can either put the parentheses around the H and the C, or I can put the parentheses around the C and the L. Does it matter which? No. So I'm just going to arbitrarily choose this for our sake. H.C.L. If all that, then R. Okay? And now we're going to proceed with our 3 moves in place. Arrow out, and in. And this problem will actually turn out the same way in the end, even if I put the parentheses around the C.L here. Because again, if you got all ands, then this whole thing isn't all ands, but the left side is. Okay? So here are my questions from here. Can I do this one? Can I do this one? Should I do this one? Right, let's proceed. First of all, any arrows not in parentheses? Yep, this one. Okay, left side match. Do I have H.C.L? No. Now look, I kind of have some of the pieces here, so you might be tempted, can I just jam that C in there? You cannot. You can only use the moves that we got. Alright, even if it seems like you can. So let's move on to the next one. Do I have any other arrows not in parentheses? No. Do I have any dots not in parentheses? This one. Right here, H.L. Let's break them down. We get this. 4 and 5, we get H and L separately. And out for both. Where did the pieces come from? Line 1. Okay. Any new arrows? No, nothing new has changed. Any other dots? Nothing new. Like, this stuff is here. It's in parentheses. This is in parentheses. This is in brackets. It's extra locked. So then the question I want to ask is, should I build anything? Now, I've said before, if your conclusion is a dot, you're going to build something. Now, do I have anything I need to build? No. Then the next question is, do you have any dots on the left side of the arrow that you need to build? Look at this, H.C.L. This is all on the left side of an arrow. We need to build this. So we got to build this first, and then we want to build this other stuff onto it. So let's build the first thing that we need. Can we build H.C? Yeah, we have the pieces. There's H, there's C. Let's build them. H.C. What did we do there? That's and in. Where are the pieces? Line 4, line 2. So now we got half, in one sense half, in one sense 2/3 of what we need here. What do we need to build on to H and C? L. Let's do that. We get H.C, because now this is a unit together, dot L. Say the pieces that you got. Now don't say here 4 and 2 and 5. No. Where was H and C together? Line 6. Where was L by itself? 5. So look, now this is the left side of this arrow. So now when I go back to this question, do I have an arrow? This has been here for a while. Do I have a left side match? Yeah, I just built it. H.C.L. There it is. What does that get me? R, which is what I wanted to solve for. So I say I did arrow out. The arrow that I used was in line 3, and the left side of the arrow was in line 7 because I built it. This problem now is done. Number 9, we got F.R.P. Parentheses around the F and the R. But what we want to solve for is F dot parentheses R and P. At first glance, it might seem like these two are basically saying the same thing, because if we got all ands and you can put the parentheses wherever you want, it seems like these are saying the same thing. Well, they are, but we need to logically prove that. Now, since it's intuited that you can actually switch between these two things, there is actually later a move that we're going to learn that allows us to just switch between these two things immediately. Like, oh, you can just flip the parentheses around. And this is called the associative property in both mathematics and logic, or just association for short. But we don't know that yet, so let's prove that this is a thing. Let's prove that you can actually, if you got this, you can just move the parentheses around. That's what we're going to do, prove it. So we're going to use the moves that we've got. We've got arrow out, and in. All right, again, can I do this? Can I do this? Should I do this? Let's see if it works. So first of all, any arrows? Nope. Dots not in parentheses? This one. Okay, so let's break it apart. It breaks down to two things. First of all, we get this nonsense, not in parentheses anymore. We get f dot r. That is and out from line 1. And also just p by itself is and out from line 1. Okay, go back to the top of the list. Any arrows? Nope, that hasn't changed. Any new dots not in parentheses? Yeah, this one. So let's break that one down. I get this F and R. Where did those pieces come from? And out line 2. And out line 2. Okay. Okay, back to the top of the list. Any new arrows I can break apart? Nope. Any dots I can break apart? I've broken apart them all. Okay, then this question. Is there anything I should build? Well, I want to get F dot R and P. Now look, I already have the F. And I actually got R and P separately. So what I'm going to do is I'm going to build them together first, and then I'm going to adjoin this. So watch this. I'm going to go line 6. I can get R dot P, half of what I need here. How do I get that? And in 5 and 3. Because look, R was in 5, P was in 3. I got that. Now what I'm just going to do here is, again, this is another sense of, should I do this? Yes, you should. I want to get F dot R and P. I got R and P. Let's put the F onto it. F and R and P, because that's a set. And I can say, I did and in there. What did I do? I adjoined line 4 to line 6, and the problem is done. Number 10, line number 1. Mom is taking a shower. Assumption number 1. Because it doesn't say this is the proof afterwards. That's how I know it. Assumption number 1. Number 2, it says, that means she's going out. What means that? Oh, if she's taking a shower. If she's taking a shower, then she's going out. Assumption number 2. Assumption number 3. She hasn't told me to get cleaned up. Now, there is a negation in there. We're going to ignore it for now. Let's just say she hasn't told me to get cleaned up is C. Okay, assumption number 3. And then it says, that means I'm staying home. Well, if she hasn't told me to get cleaned up, then I'm staying home. Assumption number 4. Okay, Mom's going out while I'm staying at home means that I'll have a babysitter. So here's what that looks like. She's going out and I'm staying at home, then I'm going to have a babysitter. Okay, assumption number 5. Then finally, assumption number 6. Okay, if I have a babysitter, it's going to be Rosalind. So, ergo, that means Rosalind is going to be my babysitter. Rosalind's going to be your babysitting name. Okay, based on these facts. Alright, let's prove it. We've got 3 moves. Arrow out, and in. Again, this one, can I? This one, can I? And this one, should I? Let's do it. First of all, do I have any arrows not in parentheses? Yep, we've got 2. This one, and this one. Do I have any left side matches for either of them? Here. So I can get either one of these. Does it matter which one I get first? Nope, but let's do it in the order that I've got them. So this one, let's go ahead and get that one out. Arrow, left side match, that gets me G. G, arrow out. Where was the arrow? 2. Where was the left side match? 1. Okay, next thing on the list, can I do another arrow out? Right here. Arrow, left side match, that's going to unlock this. I get H. Arrow out, 4 and 3. Cool. Let's take a look at what we got. Can we do another arrow out? Is there another arrow I have not in parentheses? Well, this one's been here too since the beginning. Do I have a left side match for this one? No. Okay, next question. Do I have any dots that I can break apart? The only dot I have is here, and it's in parentheses, so I can't break it apart. It's locked. So the next question I have is, should I build anything together with a dot? So the first thing you should look at is my goal an and. Is it a dot? No. The next thing you should look at is, do I have any left sides of arrows that are dots? No. No. Yes. This left side of this arrow is G.H. So if I had G.H together, I could totally unlock this B. Do I have the pieces to build G and H? Right here. Let's build it. So watch this. G.H. I'm going to build it. And in, where were those pieces? Line 7, line 8. And now that I've got this is the left side to this. So I have a left side match. So if I go back to this rule, do I have an arrow? Yep. Do I have, here's the left side, do I have a left side match? Yep, it's bigger, but it's still a match, which means I'm going to unlock B. Line 10, I get B. Arrow out, where was that arrow? Line 5. Where's that left side match that I just built? Line 9. And then here, look, do I have any other arrows not in parentheses? Yarp. I got this. Do I have a left side match to it? Right here in B. It's line 11. I can say B, it's a match. It unlocks this R. Oh, as a reminder, R is what I was trying to get in the first place, which means I can say arrow out. Where was the arrow that I just used? Here, line 6. Where was its left side match? Line 10. Number 11, line 1. This seems like a lot, but let's go through it. Mowing clockwise blows clippings towards the center of the lawn. Okay, so far that's line 1. That's C. And it says, and if this is so, and if this thing is so, then what? Beginning with 3 clockwise circuits will keep clippings off the sidewalk. Okay, great. Assumption number 1. Assumption number 2. Mowing counterclockwise blows clippings towards the perimeter. And if this is true, and if this thing is the case, doing the rest of the lawn counterclockwise minimizes mowing clippings. So that means here's what you're solving for, actually. Starting with 3 clockwise laps will keep the clippings off the sidewalk. Moreover, remember that means and. Moreover, doing the rest of the lawn the other direction will minimize mowing clippings. So we're solving for S.M. So first of all, any arrows not in parentheses? 2 arrows, they're in parentheses, they're locked. Moving on. Do I have any dots not in parentheses? This one and this one. So what this means is I can break both of these down. Which one should I do first? It doesn't matter. But I'm going to do the first one that comes first, so I get this. In fact, let's go ahead and break this one down. We get C, arrow S, freed from its parentheses. That is and out on line 1 for both. Now to be consistent, I'm going to go back to the top of the list. Can I do an arrow out now? Do I have an arrow not in parentheses? Yeah. This thing I just got. Do I have a left side match? Yeah, it was with it. It was bundled in here actually in line 1. This means I get S by itself. S. Arrow out. Where was the arrow I used? Line 4. Where was the left side match? Line 3. Okay. Go back to the top of the list. Is there another arrow out I can do? No. But there was an and out that I knew I could do from the beginning. In fact, I could have started with this one. Let's go ahead and break these ones down. We get lines 6 and 7. We get P. And we get P arrow M. Both of those and out from line 2. So we're breaking apart a dot, and both the pieces come from line 2. Go back to the top of the list. Is there an arrow now that is not in parentheses? Yep, this one. Does it have a left side match? Yeah, it was actually bundled in there in line 2. So I'm able to get just M by itself. Arrow out. Where was the arrow? Line 7. Or was the left side match? Line 6. Can I do another arrow out? No. All the arrows are accounted for. Can I break apart another dot? No. All the dots are accounted for. We already took care of those. So then I come to this question. Should I put anything together? So first of all, what you want to look for is the goal I'm looking for itself a dot? Oh, yep. There it is. I'm trying to get S.M. So are these pieces just sitting there waiting for us to put together. Do we have an S somewhere? Yep. Do we have an M somewhere? Yep. So that just means we can just stick them together. S dot M. What move do we use? This last one. And in. Where do we get the S from? Line 5. Where do we get the M from? Line 8. And this problem is done. Let's do number 12. Ooh, it sounds like science. In fact, a little bit about physics here. And even though it's longer, and it looks like 1, 2, 3, 4, 5, 6, 7, 8. I see 9 lines of text. Let's still try and break it down. And I think you'll find that in spite of the fact that it looks verbose and wordy, it's actually pretty easy once we break things down. So let's do it. First line. Momentum equals mass times velocity. That's actually just E. Assumption number 1. Okay, period 2. Today's players, okay, we're talking about football here. Today's players have more mass than the players of 1942, but move with equal or greater velocity. So think about players in the past, even say the Super Bowl winning teams of the 1960s. Take that lineup. So the Green Bay Packers of the 1960s, the Steelers of the 1970s. Take them, line them up against the worst team in the NFL today. I think you'll find that the worst team in the NFL today could stomp the best team of the 1960s and 1970s. Why? Because they're bigger and they're more powerful and they've been training for this their entire lives. Whereas in the past, that wasn't always so. So what this is saying here is this. Let's take a look. Line 2, again, the players today have more mass than the players of the past, but move with equal or greater velocity. Fact number 2. Let's look at line number 3. If momentum equals mass times velocity, oh, that's E. So if that, then what? If players today, there's that if then if language, which means we're going to have a heavy right and another arrow in here. So then if players today have at least the same velocity as, that V, and more mass than the players of 1942, ooh, there's more going on there. So I actually need to tidy this up. If the players today have at least the same velocity as, and the same mass as those players in 42, then they're hitting harder today. Okay, assumption number 3. Ooh, that one was hefty, but there it is. So let's say it again. If momentum equals mass times velocity, then if they've got the same velocity as, and more mass, then they're hitting harder. Fact number 4. If football players hit harder today than the players in 1942, then they're injuring each other more seriously than the players in 1942. Assumption number 4. So here's what we're solving for. All this proves what? That today there's more injuries going on. Why are there more injuries in sports today? All this is basically saying, hey, here's some science. Players are bigger today, they move faster, and if this science is true, and if the case of the science is true, then they hit harder, and if they hit harder, they injure each other more. That's basically what this argument is saying. Let's prove that it's true. We got 3 moves in place. Arrow out, and in. And again, can I? Can I? Should I? Let's do the work. First of all, any arrows not in parentheses? 2. This one in line 4. This one in line 3. Now, do I have any left side matches? Yeah, the one in line 3. Look, there's that E. Its left side is E in line 3. There's a left side match in line 1, which means I unlock this from those brackets, which means I just get this thing. V.M, arrow H. How do I get that? Arrow out, 3 and 1. Okay, cool. That means that's a new arrow here that's freed from parentheses. So let's see, do I have any left side matches? Do I have an H? No. Do I have V.M? I got it, but backwards. That's actually going to come in handy here in a moment. Because now the next thing I want to do is, do I have any dots I can break apart? These dots are in parentheses. Those dots are in parentheses. I don't really need to work with them. These dots are not. M.V. Let's break them down. That gets us 2 things. M and V. Where'd it come from? We did the move and out. We got both these pieces from line 2. Any more arrows not in parentheses? Well, yeah, there's this one in line 5. Do I have a left side match? No. But I have the pieces to build it. So this is, again, when you get to this phase, all right, and in, should I do it? Well, look at your goal first of all. Is our goal a dot? No. Do you have any left sides that are dots? This one is V.M. Do I have the pieces to build it? There they are. So let's build it. We get v.m. Okay, how did we get that? From those pieces. And in 7, 6. Okay, now that I got this, now do we have any arrows not in parentheses for which I have a left side match? Right here. We got v.m, arrow h. Do I have v.m? I literally just built it for this reason. What does that unlock? H. How did I get it? Well, arrow out. Where was the arrow that I used? Line 5. Where was the left side match? The line 8 that I built a moment ago. Okay, go back to the top of the list. Now, do I have any arrows not in parentheses? No new ones, but actually there's this line 4 here, this h.I. Okay, do I have a left side match for this? Yeah, I just got it. H arrow I, there's H. That allows me, and I know a moment ago I said h.I, no, H arrow I. H arrow I, there's the left side match. What does that unlock? The I? Hey, that's what I wanted to solve for, which means I'm able to get arrow out 4, 9, because the arrow was in line 4, the left side match was in line 9. This problem is done. Number 13 is one of those that looks intimidating and complicated. It's not really, it just looks that way. Let's break it down line by line. First of all, line number 1. According to Archimedes' principle, a solid body floating in a liquid displaces a volume of liquid that has the same weight as the body itself. All that, it's simple. Notice there's no ifs, ands, or buts in there. That is just D. Assumption. Line 2. If this is true, if what's true? If D is true, then what? Then the chunk of ice has the same weight as the water displaced by its submerged portion. S. All this is saying here, like if you stick an ice cube in water, the water doesn't go up by 6 feet. It only goes up by how much it's being displaced by the ice cube at the time. Okay, cool. Fact number 3. The weight of a substance remains constant through melting. C. Okay. Fact number 4. If, alright, so we know there's an arrow coming, and then we see 2 Roman numerals, which means 2 things are going to be put together, probably with an and. Is there an and in there? Yep. So 2 things with an and are going to be put together. What 2 things do we see? First of all, the ice has the same weight. Now I want to remind you, the letters here don't stand for the words, they stand for the statements. So that S doesn't stand for the word same, the S stands for the statement, the ice has the same weight as the water displaced by its submerged portion. That's S. The second component says, for example, the weight of a substance is unaffected by melting. Oh, this one, the author of your textbook's being really tricky. It's being unaffected by melting. Oh, so it's constant. Notice the word constant isn't in there at all, but that's what it means. I wouldn't do that to you on a quiz, but I just wanted you to know that's another thing that can happen. So if both those things are true, then the ice cube turns into a mass of water having the same weight as the water initially displaced by its submerged portion. 5. Provided that the cube turns into a mass of water having the same weight. Now look, it's got the word same, it's got mass. What is it though? The actual statement here that's being affirmed is W. Okay, if the cube of water turns into a mass of water having the same weight as the water initially displaced by its submerged portion, so if that thing W, it turns into a mass of water having the same volume as the water initially displaced. Fact number 5. Again, tough to figure out, because a lot of the same words are being employed. Remember, the letters here don't stand for the words, they stand for the statements. So if you go back and look at the statements, you'll see they're being copy and pasted throughout. Line number 6. The level of water in the glass will remain constant if the cube becomes a mass of water having the same volume as the water initially displaced. So there's an arrow. Whatever follows the word if is on the left side of the arrow. So listen, if it has the same volume, then the level of water in the glass will remain constant. If you put an extra ounce of ice in, the level in the glass will remain the same. Like as it melts, it'll be an extra ounce of water in it. This is also the sign when you get in the bathtub, like how high the water goes. Okay, when you put ice in your water glass, how high will the water go once it melts? This is the science behind that, and the math behind it too, and also the logic behind it. So what we're solving for is this, that the level will remain constant. So we're solving for L. So after all that translating, this was tough, but like if you can do this, you will just zoom through quiz 3. This is probably much harder than anything on quiz 3 in my estimation. So let's take a look. What are our 3 moves in place? We got arrow out, and in. First of all, any arrows not in parentheses? I see a bunch. This one, this one, this one, and this one. Any left side matches for these though? No, no, no. Yes, so let's go ahead and get that out. Here in line 2 we got D arrow S. We got a match with D in line 1. Line 7 that gets us S. Arrow out. Where's the arrow? Line 2. Where's the left side match? Line 1. Any more arrows I can break out? I got 3 more arrows here. No left side match. No left side match. No left side match. Any dots I can break apart? Oh, there's a dot in line 4, but it's in parentheses. I can't break apart. So next question. Should I do this one? Are there any 2 things I should put together? So the first thing you want to look for in this situation is my goal a dot? Nope. It's just L by itself. Vanilla L. Then what I want to look for is, do I have any left sides of arrows that are dots? No, but I already got that one. No. No. Yes. S dot C. I've got that on the left side of the arrow. So if I can get S dot C, then I can get W. So I want to see, do I have the pieces to build that? Do I have an S? Yep. Do I have a C? Yep. So build that, and then we'll unlock this. And we have the pieces to build it in 7 and 3. So let's go ahead and build it. We get S dot C. What move did we do there? And in. Adjunction. Where were the pieces? The S came from line 7. The C came from line 3. Go back to the top of the list. Can I do an arrow out now? Yeah. Because this line 4 here, S dot C, arrow W, I just built the left side of this. S dot C. I got it. This unlocks this. What do I get? W. How'd I get it? Arrow out. Where was the arrow that I used? Line 4. It's left side match. Line 8. Go back to the top of the list. Can I do another arrow out? We've got these 2 arrows here we haven't used yet. Okay, with W and V. Do I have a W now by itself somewhere that's a left side match? I just got it in line 9. So line 10, I'm able to say, hey, I get V. How? I got an arrow. Its left side is W. I got a left side match. I get V. Arrow out. Where is the arrow? Line 5. Where is the left side match? Line 9. Now with the V, go back to the top of the list. Can I do an arrow out? Yep. There's a V arrow L that's been here for a while, since the beginning. Do I have a V now? Yep. This is a left side match. It unlocks the L. The L is what I was trying to solve for in the first place, which means once I show my justification here on the right, I am done. How do I get the L? Arrow out. Where is the arrow? Line 6. Where is the left side match? Line 10. This problem is now done. Because science. And in this case, because logic. I'm able to demonstrate with these facts. It follows. The ice cube melts in your water. It's going to have the same volume, the same level of water there the entire time. Why? Because these facts, and we've proved it. So this is it on the section on conjunctions. Now you're going to have some other stuff we're going to do before we get to the next quiz on more notions about arrows and conditionals. So we're going to go to that next, and I'm going to do that in the next video. But that's what we got here when it comes to ands and conjunctions. This basically summarizes what's going on here. So that's sufficient for now.